Sketch the graph of y equals 1/2 tangent of 1/3 x. This is the transformation of the tangent function. There are two transformations here. The 1/2 in front of the tangent function is the vertical shrinking, and the 1/3 in front of x inside the tangent function is the horizontal stretching. The original function tangent of x itself has a period of pi, and one complete cycle of tangent is from negative pi over 2 to pi over 2. This time, the horizontal stretching is being squeezed between the two numbers. The endpoints are not included. And so if we isolate x, we multiply 3 both sides of the equation to get negative 3 pi over 2 less than x less than 3 pi over 2. Multiply 3 to every part of these inequalities. And so we know that this is the interval of one complete cycle for tangent of 1/3 x. Armed with this, we're going to set up the vertical asymptotes, which is at negative 3 pi over 2 and positive 3 pi over 2. We then plot a few points to make the graph more accurate. But we know that the first vertical asymptote in one complete cycle of this function is x equals negative 3 pi over 2, and another vertical asymptote is x equals 3 pi over 2. The graph of this function is very similar to the graph of the original tangent function, and so we just go ahead and sketch the graph of the tangent function again. Even though this looks like the tangent function, but it has the vertical asymptote of negative 3 pi over 2 to 3 pi over 2. What about the 1/2? If the original function, when x equals 1, in between 0 and the vertical asymptote, then this time, between 0 and 3 pi over 2, which is now 3 pi over 4, the y value is 1/2 instead of 1. Similarly, when x is negative 3 pi over 4, the y value is now negative 1/2 instead of negative 1. If we're not sure, we can evaluate these. Y equals 1/2 tangent of 1/3. When x is 3 pi over 4, we then evaluate this 1/2 tangent of pi over 4. Remember, the tangent of pi over 4 is 1, and so when we plug in 3 pi over 4 into this function, we get y equals 1/2. Similarly, if we plug in negative 3 pi over 4, we will get negative 1/2. This is only one of the many cycles of 1/2 tangent of 1/3 x. If we want another complete cycle, then we just simply copy this graph into another interval of the same length. An important observation here is that the graph of this function is similar to the graph of tangent of x. What makes a difference is the labeling. And so we can have the same graph all we want, but we need to have the correct labels. The vertical asymptote has to be, in this case, the first one, negative 3 pi over 2, x equals, and the second vertical asymptote, x equals 3 pi over 2, and any of these special points